Here we have an example of an antiderivative, an indefinite integral problem. So we're being asked to find the integral of x squared times x to the third plus 7 raised to the 7th dx. When we look down at an integral problem and we see that we got more than just a bunch of stuff being added and subtracted going on, really that sort of bells and whistles are going off that we're looking at a U-substitution problem. The nice thing about integrals is there's not a million different ways to do them. It's not like you've got product rules with chain rules inside and all the different ways you could do derivatives. When you're dealing with antiderivatives in this course, you really only have a power rule. You add one to the power and divide by the new power, or it's got to be one of your special case antiderivatives, one of your trig functions or a natural log, something like that. And if it doesn't fit those two options, guess what? The only other game in town is U-substitution. And so that's what we're looking at here. We're looking at a U-substitution problem. So U-substitution is the same set of steps every single time. Once you practice enough U-substitution problems, it really just becomes muscle memory, and these aren't bad at all. Step one of the U-substitution process is always going to be to choose the U. When I go looking for my U, I kind of have my own priority list that I've created. And the first thing I go looking for would be a natural log if that's available to me. If I don't see a natural log in my equation, then the second thing I go looking for is what I would call the inside piece, as if I was doing a chain rule problem. So something inside a set of parentheses. The third thing I would go looking for would be the bottom of a fraction. And then generally what you're looking for is you want to find the piece that has the highest power of x. So going through my priority list using this equation here, I would look over and I would say, well, I don't have a natural log anywhere in that equation, so that's not going to be my U. Then option 2 would be the inside piece. And sure enough, I have this x to the third plus 7 is inside that 7th power. So I would choose x to the third plus 7 as my U. It also is the piece that has the highest power of x. I've got x to the third inside those parentheses and an x squared outside of them. Once you have found your U, step 2 of the process is always the same. You need to take your derivative of that U. So in this situation, we would get du dx equals, and you always want to use that differential notation when you're doing this work. Finding the derivative of x cubed using your power rule, bring the power down, and then subtract 1 from the power, and then the derivative of 7 goes away. From there, the next step, step 3 of the process, is we're going to solve that equation to get dx by itself. When we do a U-substitution problem, we need this original integral here to change over to talk entirely the language of U. And that includes turning dx into a du. To do that, like I said, you're just going to treat this dx like any other variable, and you're going to solve this equation to get it by itself. So the first move here would be to multiply both sides by dx to get that out of the bottom. We end up with du equals 3x squared dx, and then we would go ahead and just divide by 3x squared, divide by 3x squared, and we end up with du over 3x squared equals dx. Now we're ready to go do the substitution part of our process. We're going to take all of that and we're going to substitute that in for dx, and then we're going to take our u and substitute it into the equation. So what I always tell people is you just want to work your way through this original integral left to right, and it's either one of the things you're going to substitute in or it gets left alone for the time being. So working our way left to right, nothing happens to that integral symbol. Nothing happens to that x squared. Now all that stuff inside the parentheses there becomes my u to the 7th. And then dx is now going to become du over 3x squared. At this point in your process, any x's that were left in the equation should cancel out with x's you just plugged in. You need this equation to talk nothing but the language of U, so you need those x's to go away. And sure enough, x squared on top and x squared on bottom cancel each other out. And then you rewrite what you've got now. So keep in mind there's this 3 down here. It's on the bottom of a fraction, so that's really a 1/3. And you want to slide those constants to the front. So this would be 1/3. then I've got my u to the 7th du. And that right there, this is what I call your reward for all that hard work. This is a brand new math problem. What you've done ideally is taken this original integral that you could not handle and ideally turned it into an integral that you do know how to handle. So this integral here better be either a power rule or one of those special cases that you have memorized. And sure enough, on this one, we're going to have just a straight up power rule going on. So the power rule for antiderivatives, my saying goes, add 1 to the power. And then step 2 is divide by the new power. So in this problem, we would add 1 to the power. We get the 1/3 coming along for the ride. This would be add 1 gets us u to the 8th, divide by that new power, divided by 8, and then plus c. Then the last move on a U-substitution problem is you remind yourself you didn't really care about u, you cared about what u was. So we're going to plug the u back in. We'll do a little bit of simplification, 1/3, and that's an 8 on bottom, so that would end up being 1/24. And then instead of u, we replace it with what u was, x to the 3rd plus 7 to the 8th plus c. And that right there is going to be your final answer. And you just go and look for what it is in the answer options. And sure enough, here we have option C. So U-substitution, same set of steps every single time. Just practice a bunch of these and it'll be super easy on the test. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.